In quantum mechanics, there is a classical conclusion that a pair of entangled particles, no matter how far apart, share a connection that could enable faster-than-light communication. I will now explain this phenomenon using four-dimensional space. The following explanation is based on my personal hypothesis and has not been proven. The understanding of four-dimensional space is challenging, so we start from three-dimensional and two-dimensional spaces. In the illustration, there is a sheet of paper and a Rubik's Cube. The Rubik's Cube is a three-dimensional object, while the sheet of paper represents a two-dimensional plane. When you lift the Rubik's Cube and look at it, the part of the cube that touches the sheet of paper shows only one red face. In the two-dimensional plane, there is a white sheet of paper with a red square on it. When flipped, it becomes a blue square on the white sheet. The pattern left on the white paper changes with the rotation of the Rubik's Cube. Now, if we roll up the white paper, it remains a two-dimensional plane. However, the Rubik's Cube will have two faces on the white paper. In the two-dimensional plane, as shown in the diagram, when we rotate the Rubik's Cube, the square on the paper changes to blue and green. Upon another turn, it becomes white and yellow. There is a corresponding relationship between the two squares on the white paper. From the unfolded diagram, it can be seen that one is orange and the other must be red. One is blue and the other must be green. One is white and the other must be yellow. No matter how long the piece of paper is, as long as you turn the Rubik's Cube, two squares change simultaneously in an instant. Isn't this very similar to quantum entanglement? A pair of entangled particles, no matter how far apart they are, have some kind of connection. This connection ignores distance. So-called entangled particles in four-dimensional space. Are they just two different parts of the same object? In three-dimensional space, they are far apart. But in four-dimensional space, they are very close. Just like the two faces of this Rubik's Cube. No matter how far apart they are on the piece of paper. In three-dimensional space, they are only one edge length away.